Lesson 3.3, graphing derivatives and antiderivatives from graphs. So this has to do with looking at derivative graphs and be able to understand it, analyze it, be able to use it for different things. If you have a function, what would the derivative graph look like? So if I look at this function, and let's say you draw a number line for the first derivative, what I want you to notice to transfer this into a derivative graph is where are the turning points here. So at -2 we have a turning point, and at +2 we have a turning point. And really there's not arrows at the end. It goes from whatever that number is, -3 something to +3 something. And then I want you to think of increasing and decreasing. So this graph first increases. That's positive for the derivative. Then it decreases. That's negative. And then finally it increases. So when I come over here to the graph, these numbers is where the derivative is 0. I want you to think of the slope at those points. So when we have a turning point, we take the derivative and we make it equal to 0. So a turning point is taking the derivative and equal to 0. That's because a horizontal line for a tangent creates a turning point. So when the slope is 0, that's a turning point. That's a big, 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 big idea. So the derivative, where is it 0, is at -2 and +2. Where it's positive, it's above. And where it's negative, it's below. I also want you to notice that we do have a point of inflection right here in the middle where it changes concavity. So at 0 is a turning point for the derivative. And there's your graph. So it's important to make number lines and really talk your way through the graph so we understand what we're looking at and what we're doing. Let's practice it again. Turn the page. If I look at the derivative here, and I would do a number line, again, we have endpoints there. So now it's the derivative of what I'm looking at. So what I'm looking for here is where the derivative is equal to 0. And at 0, it's equal to 0. So for a derivative number line, looking at the derivative, now it's above or below. So the derivative's above and then below. When I look at the second derivative, I'm looking for turning points on the derivative. So for the second derivative, where are the turning points for the first derivative? Where is the slope? 0 for the tangent. So at -2 and +2. And then for the second derivative, from the first derivative, increasing and decreasing. So it increases, then decreases, then increases. Then how do I transfer this information to the function? So I know it increases and then it decreases, which means at 0 we have a maximum. I know it's concave up, concave down, and then concave up. And I want to put that information on this graph. So our starting point is at 0, 1. At 0 we have a maximum, so that is going to be a local maximum. It's going to increase to it's going to increase up to 0 and then go down from 0. I need to know at -2 we have a point of inflection, and honestly anywhere below works because it's rising, so anywhere below works. So at -2 and +2 I have points to guide my concavity. They could have been higher a little bit, but it must be lower than the maximum. And I know at the end of the graph, which is at like -3 point something, it still must be lower. So I'm going to create a point at 3 something lower, so it's rising up here. And now to connect the points we use concavity. So this is concave up, then it's concave down, and then it's concave up. And so that matches these number lines. It rises to 0 and then falls. We have a maximum here. It's concave up, then concave down, and then concave up. It's going to take practice, and how you pay attention to it is going to be important. Number 3. It says use the graph of the derivative and the second derivative and a possible graph of the function. So take the derivative, and we're going to do a number line. and I'm looking for where are the x-intercept here. So where is the derivative equal to 0? So that would be at -2. And before -2, it's below, and after -2, it's above. So at -2 is a minimum. For the second derivative, I'm looking for any turning points here. There are no turning points. This first derivative is increasing all the way through. That means the second derivative is positive. Now, we do have a point right here where the derivative does not exist. So at 0, the derivative doesn't exist because we have a line and a parabola connected. But outside of that, it's concave up throughout. So if I work backwards or work towards the second derivative based on this, the whole graph is above. This gets a little challenging. When I do the derivative of a derivative, I'm looking for the slope of what I'm looking at. So when it's a line, the slope is constant. This slope of this line is up 1 over 1. So I'm going to draw a line at +1. When I get here to 0, it's undefined. So I'm going to put a hole there. So this is telling me we have the slope is 1 forever up to 0. So this slope is 1, and I'm showing that here. This shows me the slopes. At 0, the derivative is undefined, so that's why there's a hole. And then what's happening after? It's still increasing. And so when I think of the slope right there, it's undefined. And then when I think of the slope, think of this like a parabola. So think of it like x squared. It doesn't matter if it's x squared plus 2. When you take the derivative of that, now what you're graphing, so if this is this, then the second derivative, the derivative of that would be 2x. So if I was graphing 2x, it would be a slanted line, rise over run, and you draw that. It's a little bit challenging, think of it in terms of slope. And notice again, we have a hole at 0 because it's undefined. So maybe understanding what the equation of the graph is and then taking its derivative could be helpful. Going in this direction, we don't have any starting points. I know there's a minimum at -2. So at -2, we have a bottom point. I don't care where that bottom point is. It's going to go down and then up. So I know at 0, oh, and the whole thing is concave up, except at 0, no, the whole thing's concave up. So all I have to do is draw it concave up, and it's done. So it's concave up with a minimum at -2. Done. So these are working with each other. All right, there's your lesson on graphing derivatives. You're really going to learn it as we do our assignment together, and you do your best. Mr. G Math, over and out until we do the assignment.